Hello, in this video we show how to create tensors for the time series data as inputs to PyTorch for deep learning. So we can first read CSV file as NumPy, then transform to tensors, and this is the 2D tensors, two-dimensional. And then we transform it as a three-dimensional with one dimension for the time series, for example, hour. And we show example for the bike data with weather and hour variables. Then we go to Python. First, we load module and set the working directory. Then we load a CSV file into NumPy array. So using load text function for this CSV file, you can see there are about 17 columns for the index and the date, and we have also our data from 0 to 24, and we will use this for time dimension, and weather and temperature. So we will show how to handle these variables. First, in the reading function, we set float and delimiter for the comma, skip a row first, and we use converters because we have to take out two numbers for the day, because in the original data, the date is quite a long string, so we only take these two for the date. Then we create a tensor from this NumPy array using torch.from NumPy. So now the bikes is a tensor of 2 dimensions. All the numbers are floating numbers. And we show the shape and strides of this tensor. About 17,520 data, and each example has 17 columns. And stride 17 one, which means if we move from one row to the next, we'll move 17 positions in the storage. And if we move one place along the column, then it only move one place in the storage. Then we will transform to 3D. We will use a view function. So view function will set the second dimension as 24 because there are 24 hours, and third dimension is the original tensor's second dimension, which is 17. Then we set a -1 here, so it will be filled with dimension for the shape number for the first dimension automatically. So you can see the shape and the stride again. So now the shape is 730 and 24 and 70, which means 730 days, 24 hours, and 17 variables, right? And this is the stride. For example, if we move from day 1 to the second day, then we move 408 positions in storage, because there are only 2 days data, but there are so many hours. And we have to transpose these 2 dimensions because we will want to set the hour dimension the last. So we will use transpose function for the PyTorch for the second and third dimension. Show the shape and the stride again. Now 1724. And next, we will set the weather data as categorical. So we use a one-hot encoding because the weather data originally is 1 to 4. Then we will set as a one-hot encoding. If for example the data is 1, then the second position will be 1. The data is 1, the first position will be 1, and 4, the fourth position will be 1. And first, we will take a first day. So we use the original 2-dimensional tensor. First day is first 24, right? Then first 24, if we show, so there actually is 24 by 17, right? 24 hours by 17 columns for this 2-dimensional tensor. And we want to find, because the weather data column is 10th column, so we will transform to categorical one-hot encoding. But first we have to create the data for the weather one-hot encoding. So weather one-hot is the first day, shape 0, 24 hour, then with 4. Because weather data has 4 level. So we create a tensor with the shape 24 by 4 first, and with all the values 0. Then we show the first day's 10th column for the weather data. For example, there are 24 hour with the weather 1, 1, 2, 3, but no 4 here. Then we use a sketch underscore function. We'll put these 24 data according to their value. Then we'll fill in 1 in this weather one-hot. This shape is 24 by 4, right? So we will fill 1 for according to the value of 24 weather data. We use scatter and along the dimension, second dimension, for this data, for this tensor, for the second dimension. The index is from this object's value, but we unsqueeze to 2-dimension 2 and to the integer value -1, because the weather data from 1 to 4, we will transform them as 0 to 3, because the shape for this is 0 to 3. So, and we fill the value 1.0. Then, which means whether one-hot has been filled with 1, right? You can see now this has been filled with 1 according to their temperature value. Then which position will be 1. Then we can catenate, for example, the first day's 2-dimensional tensor with weather one-hot. Then we show the first row. So now the first row has 21 variable value, because the original row has 17 value, now has 21. So which means this is correct, because the last 4 is the weather one-hot encoding. So next we will do this kind of job for the odd tensor. Then we create daily weather one-hot for the 3-dimensional tensor, which is daily back shape 0, daily back shape 2. This is same as daily backs. Daily backs is a 3-dimensional tensor we have created, right? Then for the second dimension, we set shape is 4, because we will fill in the weather data as a one-hot encoding for this dimension, same as we done for the one data value. So this 0 3-dimensional tensor has been created. We show shape is 730, 24, and 4. We will fill this with 1. Then, similarly, we use sketch underscore function along the second dimension for this 3-dimensional tensor, and we fill in the value from daily back's 9th and 10th column from the second dimension. This is the weather for all the data. They unsqueeze to the same shape as this one. Then we minus 1 because weather data from 1 to 4. We will use 0 to 3 to fill in. Then set the value 1 according to the value and set the position for each row of these 4. And we're done. And next we show this shape as same as before. Then we will have to concatenate this tensor to daily back's tensor along the dimension, second dimension. We use touch catch function. And this is one kind of encoding, one hot. But you can also, for example, we do not use this kind of approach. Another approach like daily back's just second dimension's 10th column minus 1 divided by 3. Because this value between 1 to 4, right? So we can minus 1 and divided by 3, which means the value will be between 0 and 1. Because the largest temperature 4 will minus 1 equals 3. So 3 minus 3 is 1. But if the lowest temperature is 1, so the value will be 0. We can also do this kind of approach if we treat temperature as continuous variable. Then we can also do another approach like this is the weather. We have to this is the weather variable for the temps, but for the temperature is continuous, right? So temperature 11th column. So for the temperature, we will treat as a continuous variable. Then we will use minimum, maximum normalization scaling. So we will get the temperature minimum and maximum for this dimension, and we'll minus minimum value and divide by the maximum minus minimum value. So the temperature will also between 0 and 1. But also you can use normalization to get temperature as standard deviation 1 and mean 0. In this way, we will, for each temperature minus its mean value divided by its standard deviation. So in this video, just for conclusion, we have done 3 jobs. First is transform the 2-dimensional tensor as a 3-dimensional, which takes the hour as the 3rd dimension. And second is transform the weather, because weather is categorical variable. We treat the value from 1 to 4. Then we will treat them as one hot encoding with 4 columns according to the value 1 to 4. Then which column will be filled with 1. Then we concatenate this one hot encoding to the original tensor. Third job is transform the temperature, which is continuous variables, by 2 approaches. One is using scaling minimum, maximum, and second is using normalization, which will return the temperature as the value with mean 0 and standard deviation 1. So after this kind of tasks, the data can be created further, for example, with a batch size, so the data will be 4-dimensional, can be input as a PyTorch deep learning module. Thanks for watching.